In this lesson, we're going to be talking about transformations of exponential functions. So we have to remember that if we have an exponential function and there's this a out here, a is the initial value as long as there are no translations, meaning no shifts, particularly left, right, up, or down. So if there's any h values or k values, then that is going to affect that initial value. So a can also be thought of as, if it's negative, a reflection over the x-axis, a shrink, or a stretch, depending on if a is between 0 and 1, a shrink, and greater than 1, a stretch. H, so a number with the exponent, shifts left or right. And this one, it's tricky because it's the opposite sign that you see. So if it's negative, it's going to shift right. And if it's positive, it's going to shift left. And then any k values being added to the function, that would shift the graph up or down. Another point, other than remembering that a is the initial value of the function, but with no transformations, a horizontal asymptote also exists with exponential functions, so any shift up or down will change the horizontal asymptote from y equals 0 to whatever the k value is. Okay, so let's take a look at some examples. Our first example, we have f of x is equal to 2 times x to the third plus 5. So thinking about this function and identifying the transformations that are going to occur, the 2 to the x power would be the base function, the parent function, if you will. And then this minus 3 is a transformation, and this plus 5 is a transformation as well. So remembering the ones with the exponent, those are going to be either a left or a right transformation. This one, since it says minus 3, is going to transform right 3 units. The k value plus 5 shifts the graph up or down. So this one is shifting up 5. Since the graph is going up 5, the asymptote, which is originally located at y equals 0, is going to also shift up 5 units to y equals 5. The domain of the function will always be negative infinity to infinity. You can plug any value in for x, but your values for y, since this is a growth function and it's shifting up 5, it's never going to go below the line y equals 5. So our range is going to be 5 to infinity. Okay, the next example, 5 to the x power would be the parent function. Plus 1 is a transformation. Minus 6 is also a transformation. So the transformations that are occurring, we're going left 1 unit and down 6 units. H is 1, K is 6. H is actually negative 1, excuse me. Okay, the asymptote, since this function is shifting down 6 units, the asymptote is also going to shift down 6 units. So y equals negative 6 is the location of the asymptote. The domain is from negative infinity to infinity. And the range is again a growth function because b is a value greater than 1. But it's never going to go below negative 6. So negative 6 to infinity would be the range of this function. Okay, so now we want to write some functions that are being translated. We're going to use the parent function, f of x is equal to 3 to the x, and then just think about the different transformations and how that would affect this function. So if we're translating the function down 3 units, that's going to be a k value, and k is going to be negative 3. So f of x is raised to the 3x power minus 3. Okay, number 2, we're translating up 1 unit. That's a value of k. And left 9 units. That's a value of h. Okay, so we would have f of x is equal to 3 to the x minus h, careful with signs, plus k. So we can clean up those signs. F of x is equal to 3 to the x plus 9th power plus 1. Okay, the next example, we're translating right 6 units. That would be a value of h. So f of x is equal to 3 to the x minus h power. And then number 4, it's stretched by 4. That's a. Translated up 2 units, that's k. So we would have f of x is equal to 4 times 3 to the x plus k.